Hi, John Evans from Cisco, but here representing Panda. It's actually pronounced Panda. We were originally called Panda. We had to lose an A for trademark reasons. We still like to think of ourselves as Panda. Panda's a Linux Foundation project which aims to make big data analytics more easily usable, accessible, and applicable to network, both from an operational perspective, but also other contexts at looking at the application of analytics. Could I just do a quick show of hands on who in this room readily uses big data analytics, anything from Hadoop or associated technologies in what they do? Okay, so we've got a small smattering. So I think to put some of this into context, to people that don't work in that space, it can seem quite daunting, quite frightening, as any new technology space is a little bit to the uninitiated and even to the initiated. And Hadoop's probably one of the worst areas for this, because within the broader Hadoop ecosystem there are 100+ technologies. All with different names that are completely unassociated with each other, and it's quite difficult to fight your way through that. Don't be daunted, and I'll try and I guess I'll try and explain some of those points and how we're looking at the application of big data analytics. So I'm going to start with I'm taking the brave step of trying to present to you lot a simplified view of an OSS stack. Feel free to throw things at me. So start with very simplified view. Got a customer. Customer places an order. Order goes down into some sort of order management system. I'm going to call this the BSS layer, which understands the customer but doesn't understand the network. That gets handed off to some provisioning or activation system. I'm going to call this the OSS layer. Understands the network, doesn't understand the customer. That gets provisioned. A service is enabled. Okay, great. We've got a service up and running. But then there's a flow coming back, which is that service is going to produce data at multiple levels and at multiple layers. That data is going to come and flow back up the stack. It's going to flow back into an OSS system, which understands the utilization of this service, but doesn't have any context of what that means. That may then feed up to a higher layer, which understands that's the utilization of that customer and represents, some usage of their quota, which then goes and hands off to the customer. So now you could, I guess, work for the viewer. You could take this away and try and map this to frameworks if you were feeling sadistic. But let's try and map this to what's going on today. So there's a huge amount of work that's been going on in orchestration and automation. And on my diagram, that's kind of addressing this provisioning and activation block. There isn't so much by the way of equivalent work addressing the analysis of the data that's come out of those deployed services. Not in a structured way. I think there's a lot of effort. There's a lot of work going on in a fairly piecemeal way. In OSS terms, this is where we could put the FAPs from FCAPs, but it's really addressing a much broader set of stuff. It's not just fault management and assurance and performance management. It's really looking at the broader use of the data coming out of those deployed applications and services, which could be for security analytics, it could be for behavioral analytics, it could be for many things. Now, I'm going to put forward the thesis that today, if we're going to look at the application, if we're going to look at that space, the analysis of the data coming out of the deployed the deployed services, then really, if you're doing that today, you're not going to use the same technologies that we would have used 5 years ago. And the Hadoop ecosystem, the technologies in the broader Hadoop ecosystem have really fundamentally changed the landscape for how we deal with data processing. And what this means is that in that orchestration stack, it's entirely the wrong set of technologies to deal with large-scale processing of data. Maybe exactly the right technologies for enabling a service, but it's not the right technologies for dealing with large-scale data processing. Now, what we used to do was we used to have a system, maybe we had an EMS which dealt with the configuration of a device and it dealt with the analysis of the data coming out of it. I'm going to put forward that that's not the way things are going to be in future, that actually we're going to have a bifurcation of that stack where we've got stuff dealing with automation, we've got stuff dealing with analysis, and there's going to be a coupling between those. And the fundamental reason for that is because of this change in the software landscape for how we deal with data processing. So I'm going to say that we're on that we're in a shift in terms of technologies that we apply in that space. So what's going to change? At this point, I think it's important to understand a couple of the fundamentals in Hadoop and the big data analytics space. There were two key papers that were the foundations of Hadoop. One was the Google paper around distributed file systems, and the other was then around MapR. So the distributed file system paper was really talking about how do we come up with a redundant, resilient distributed file system on underlying commodity infrastructure. MapR was then saying, okay, on top of that infrastructure now that we've got a distributed set of data, how do we process stuff on top of that? And how do we do that in a scalable and performant way? And with MapR, the MapReduce, the approach to doing that was effectively to take the processing to the data. So that technology landscape, what it deals with is breaking up the processing, sticking that out close to the data to be able to give you performant parallelized processing of data. And then the broader Hadoop ecosystem, I guess, layers things on top of those concepts. So if we look at where things have been and where I would say things are going, what changes? There are a number of things that change. So if we have an RDBMS-based performance management system, we've got a limit to how much data we can put in it. Those kind of limits implicitly mean that you end up with siloed domain-specific things. Can I take my metric data from everything and dump it into my network performance management system? No. So implicitly you end up with sort of siloed domain-specific solutions. They end up being, fairly tool-driven. I want a performance management system. I look at Gartner, Magic Quadrant says, go with these. I put an RFP out. I select one. I go with it. But then you're kind of tied into what you can do with your performance data based upon the product. And a change requires a change to the product. So it's a kind of, I guess we've been in a fairly tool-driven or tool-constrained space. And implicitly, because we've had domain-oriented solutions, they tend to be fairly closely coupled. The aggregation of data fairly coupled to the storage of the data, to the analysis of the data, to the output of the data. Because of that, they end up being fairly tightly defined. And I guess we're coming from a world where I should say schema rather than scheme, which is pretty much based upon a schema on write type model. So the big data world really kind of focuses more on a schema on read model. So what does that mean? Well, rather than having a very, very tightly defined schema up front for your data, where you take it in, you normalize it to that schema, and then it's stored in that way moving forwards, and that schema then limits what you can do on the data afterwards. You take the data in raw, you store it as raw as possible, and the schema is applied on write and processing of the data, not on read before you store. So if you choose later on to want to view your data in a different way, there's no problem with doing that. You change your application, which changes the way it views the data, rather than change your schema on write, which fundamentally changes the data. So then, these changes in approaches lead to some big changes in what we can do. Much more flexible ways that we can deal with the analysis of the data, more things that we can apply to do with it, and more scope for change beyond what you do at the, if you like, design time, more scope for change at runtime. So you may or may not accept my thesis, but let's have a look at what typically happens today. So today if you want to go and apply big data analytics, you've got two extreme choices, let's say, and I'll paint extremes of a spectrum. One is that you can go and buy or use an analytics application. So something that has been built to do a specific job. If you do, generally, things that have been built to do a specific job in this space may do that job well, but they're relatively inflexible when it comes to trying to apply them to other things. You may have a performance management analytics solution. Can you then take that same data, that same system, and use it for security analytics? Possibly not, even though it's the same underlying data that you may be using, even though actually some of the underlying principles may be the same. The other end of the spectrum, you can go to the broader Hadoop ecosystem. You can take the technologies. You can integrate them to do whatever you want. But that is a software integration task. And in doing that, you're taking on a software development role. And that's practically what is done very frequently today. Hadoop ecosystem is a complicated space, and if you give any two teams the task of developing a solution based upon the technologies in it, they will come up with a different answer. They don't need to come up with a different answer, but it's just inevitable, given choice, and different opinions, that they will. And so what you very commonly see today is many siloed solutions taking different technologies from the Hadoop ecosystem, integrating them in a way that a team will consider appropriate. But what that means is, effectively, that's a custom integration and a custom solution, and they have to own and manage that for its lifetime, and it will then be pretty much a silo from all of those other developments that have happened. Now, practically speaking, that doesn't have to be the case today. And if you look, I think it's pretty common that there is a significant amount of duplication between these systems, and that's something that we've tried to take out in the work that we've done in Panda. So what is Panda? So Panda is it's a midstream, what's being called a midstream project, which means we've taken from upstream projects. We reuse a number of the components in the from the Apache Foundation, and they are bound together with a set of development that effectively gives you a complete platform for network data analytics, which includes installer, configuration, integration, management. So the idea is to make the job of applying big data analytics far easier. Rather than having to develop your own pipeline, Panda gives you a pipeline, you can then focus on developing the application. So it is a platform, it provides a common set of services. If you install Panda, at the moment we support bare metal, OpenStack and AWS. After about an hour install from a one-line CLI, you'll get a working Panda cluster. Panda cluster includes a whole set of underlying technologies that deal with the storage of the data, HDFS from a distributed file system, but then HBase and OpenTSDB to allow different options for different data stores. They are all layered on top of HDFS. And then different processing, stream processing, batch processing, Spark and Spark streaming, and then ways to visualize and explore the data. So in terms of why would you consider using Panda? Well, I think the first thing is, if you look at the Hadoop ecosystem, it's actually very complicated to fight your way through the tree of technologies that are there to select which particular branches you're interested in. We've done that. That's been part of the core Panda development. But then, even once you select those technologies, the job of integrating them together is a pretty big job, and we've done that. This is the result, and I apologise for the impossible to read slide. It's probably easier on when you download it. But if I just talk you through the color coding, which will give you an idea of what Panda is and what it's not. Anything in green is effectively Panda code. Okay, that's the stuff that has been developed for Panda. Stuff that you see in purple, that's upstream. That's stuff that has been used directly from upstream, and as those upstream things evolve, you know, new versions get pulled into Panda. So the green is what takes care of the installation, the configuration, the management of the entire cluster. I'm going to hand over in a second to my colleague Joel. Some of you might know Joel Obsfeld. He's going to show you some of what we're doing in terms of application development on top of Panda. Our goal is, you know, the aim is to create a healthy community around Panda. We've got people at the moment developing multiple different sorts of applications on it, from service assurance through consumer video analytics, through core IP network operations, and I think Joel's going to show you some of what's being done in terms of BGP. But I wanted to, before I hand over to Joel, kind of point back to one of the key changes was this difference between design time and runtime. So in the big data analytics space, the data science space, they take a much more flexible approach to what they do with data. And as part of that, they have defined a data science life cycle. And the data science life cycle effectively is considered it's considered a circle where you go from a business problem to exploring through data, through deploying something to provide you with an answer to that, to then going back into the business and cycling through. So they don't consider it a sort of you know, it's ever a finished job. Now the technologies that you apply also change depending upon the life cycle. So what I show here is on the right-hand side, you'll see Jupyter. If you're familiar with Jupyter Notebook, it was previously called IPython. That's essentially it's a notebook development environment for exploration through data. An important point here is that this stage where you're trying to actually understand what's going on with the data and find a solution, you don't need a big data platform at that point in most cases. You can prototype, you know, locally small data to understand the solution to a problem. But then when you start to look at I've got a solution now, I want to deploy that in production at scale, then, you know, we point here to Panda Pico. That's currently our smallest installation of Panda, which is non-resilient for development. It's aimed to be, you know, a small cluster. But then when you get to deployment, you know, you'll want something that really is capable of big data at scale, and that's where we've got the Panda standard flavor. So on installation, you can choose which flavor you want. The key point I'm trying to make here is that, you know, depending upon where you are in the life cycle, there are different technologies that you'll apply to try and solve those problems. Okay, that's a point where I'll hand over to Joel, who's going to talk a little bit about some of the stuff we've been doing in BGP.
Thanks, John. Good morning, everyone. Great, 5 minutes. Okay, so let's bring that back into context and talk a bit about how we can bring those two areas together. So the big data elements that John just talked about, and something close to many of our hearts probably, BGP. Right, so when we're looking at the application pieces, and this is nothing to do with this particular application, this is just general guidance on big data application lifecycle development. Most data scientists have no clue what BGP is. Right? They are historically called statisticians. They understand formulas, they understand maths. BGP, what are you talking about? So they need you guys, because you guys live, eat, and breathe this stuff. They don't. So you have to work with these guys to be able to take what's in your heads and convert that into something which is meaningful. Formulas, you know, looking at data. They couldn't tell you what is an interesting event in a BGP set of data. It means nothing to them. So they need you guys. We needed somebody who can do that data science, right, the statistician side of things, and convert that into applications. And ideally, if you're thinking about, okay, how do I then take this into an application I can put in my NOC, for example, so as Brian was talking earlier, somebody's got to then take that data and wrap it up and present it and turn it into a useful tool. So, you know, somebody who can do the web development side is really, really part of that program. So what we'd used for this is we've taken, people familiar with something called OpenBMP, the BGP monitoring protocol? Some people vaguely nodding. Okay, if not, have a look at it. Effectively, it's a BGP collector, but you're getting raw data feed. So it's not doing the best path selection and saying, oh, here's what I decided. It's actually giving you the raw stuff that you're seeing from upstream. So what we did is we took OpenBMP, and this is just a quick diagram of what's inside OpenBMP. Take a look at openbmp.org if you want to take a look at more of that. And effectively what you're getting is this live data stream of all the BGP updates. What we then did is to bolt that into Panda. So we have to take the data from OpenBMP, do a little bit of conversion work. You have to wrap that up. We use something, Logstash, probably a lot of people are familiar with. There's this thing called encoding, a codec, something called Avro encoding, that just converts it into a form that the Panda platform can readily consume. Okay, so it's take the OpenBMP feed, wrap it in this Avro encoding, fire it into the Panda cluster. So it's coming out of our OpenBMP collector, comes out through the Logstash agent, and then it goes in across a Kafka bus, and then we start doing our processing. So in this case, we've now got our big data platform, and it's receiving BMP, live BMP feeds. So that's where we're starting to build out our data lake. And as John said, raw data, and as much of it as possible, thank you, rather than processed. We want the raw stuff. Then we start doing our work. We start looking at the analysis pieces. What's interesting, what's actually in here. So we're using something called a Spark batch job. John mentioned it before. Basically, Spark gives you two modes of operation, a batch job or live streaming. Effectively, just a batch job that's running more frequently. There's some subtleties to it. And then we've got our application that's sitting on top of that. So that's the piece sitting up on the right-hand side. So our web front end, it's now talking into the Panda cluster. And we present a REST interface and we get our data out. Okay, so as we said, OpenBMP gives us an ability to listen. We see all the various feeds coming in from our peers, and we can process all that information, try to understand what's going on. We're using the Panda cluster to give us that large-scale recording capability. And what's really nice about this is it scales horizontally. You got more data, no problem. You just throw more systems into it. It can be, it's designed to be scalable without having to do a complete reconfiguration. And the parallelism. This is designed for doing things that we think are hard. It's not hard. It's just we haven't had access to these kinds of tools before, and now we're starting to see, okay, what's a real big data problem? Is BGP data really big data? Not as such, but if you wanted to say, I want to see a year's worth of BGP data, okay, now we're starting to get in the right direction. Remember, this is designed for every house in the country having smart meters. That's a completely different proposition, but the technology is completely applicable. So we want to be able to ask a question of the entire internet. Here it is, I've got the data set from the entire internet, what is going on? That's quite tricky to do until we start using some of the power of the parallelism. But we also want to be able to do the, on the per prefix basis, really drill down. Okay, so now I'm going to need some technical help. How do I drive a video on here?
Nobody said there was a video.
Oh, sorry, there's video. Okay, you have to wiggle a mouse, I think, and there should be a little play button thing, I hope. Oop, go back one. Oops. There it is. See? Yes. Okay. So.
Is there audio with that?
No, no audio. Okay, so what we're going to show you, this is a Panda cluster. This is the front end, something called the console. And what we're seeing there is data is being ingested. So we've got our OpenBMP streamer firing data in. We can see the volume that's coming through. So this has been running for a few days, and we're seeing about, as I said, sort of half a gig of data a day coming into that. That is actually quite low volume for a big data platform. As we said, we've got the raw data here, so we can dive down into that data. So you want to ask some different questions? No problem. It's there. This is raw BMP data. You can grab that data out and go ask your own questions. Don't like what I'm asking? No problem. You can get access to it. And you can create multiple instances of this. So if you had two different development teams looking at two different problems, you could give them their own applications to really go digging into this stuff. They're completely different data sets. It's the same underlying data, but you can manipulate away, have all that information. As John mentioned, this thing, Jupyter Notebooks. You might have come across it before, IPy notebooks. It's an evolution of that. So you can, if you're comfortable with Python, you have people who are comfortable with Python, write your own experiments on the data, as John said before, look at this stuff. Use various Python libraries. So here we've got some graph plots that we're looking at. To experiment, visualize, see what's possible. And if you're happy with it, now you start doing that the data development to actually turn into an application. So what we're showing here, this is again very quick, this is OpenBMP's UI, which we've extended. What we're doing is we're plotting all of the ASs that have originated a prefix. And then we're also able to see how many prefixes are transiting through any of these ASs. Then we can just do some lookup so we can see who's advertising what. But then we're able to do things like this. Okay, so this is raw BMP data, and we're able to see every AS path that we've ever seen. Okay, so we can dive down, we can see how many prefixes are being originated, how being transited, who's connected to who, filter and visualize. This is just one way of looking at the data, but it kind of looks at this kind of, but think about the practicalities. We can actually do time slices, so we can see how things are actually adapting and changing and evolving. Would you use a plot like this? No, maybe not. Is it good eye candy? Well, hopefully you like it. But the point is, what we couldn't necessarily do historically, we can do because we're starting to leverage the parallelism that we've actually got in the tool set. So hopefully food for thought. This is still a work in progress. We're actually sort of going to be demonstrating much more of this capability at Cisco Live in a few weeks' time. But hopefully it gives you a sense as to what's possible. But where are we going with this kind of stuff? We want to be able to ask questions which a lot of people in academia have historically asked. So can we look at stability? Can we identify through signatures things like security events? And where we really want to go is, can we get into weather forecasting? Imagine being able to say, yeah, we know, because we've seen this kind of pattern before, this sequence of events means something is coming. Can I actually get to the point of view of prediction? So some food for thought, maybe a little bit of vision, but there we go.
Okay, thank you, John. Thank you, Joel. Any questions for our speakers? We've got time for 1 or 2 questions. Okay, Kat.
From the register.
Oh, can you wait for a microphone, please?
Oh, okay. Kat Hall from the Register. John, quick question. Panda's obviously a relatively young project. What are you doing to attract more members? And presumably you need buy-in from some of the other big players like Huawei and Juniper. I've not seen them on the list of people to sign up yet. And what's the kind of roadmap for this year? Yeah, so we're actively cultivating the community at the moment. We've got a number of people looking to upstream things. So we are growing and we're open. So if anybody is interested in being part of that community, it is an open project. This is not in any way a police project. It's a Linux Foundation collaborative project. So yeah, come and join us. We are, I think, over the next probably 2 to 3 months, there'll be a number of efforts that you'll see upstreaming into Panda outside of Cisco. Can you name anyone that's
no, not here. No. I can give you some indications. Work around containerization within Panda, work around security analytics.
Okay. Any further questions?
But that does lead to a general open call that this is, if anybody is interested in using Panda, you can go and download it. You can install it. There is community support behind it in terms of helping you to get going. And yeah, we welcome any contributions. Thanks.
Okay, thank you.